Lesson 5.3, Bisectors and Triangles. Today we're going to be looking at circumcenters and incenters. A circumcenter is a point of concurrency of the perpendicular bisectors. So here's the concurrency of perpendicular bisectors theorem. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So if you draw a triangle and you construct the perpendicular bisectors, so first of all, I would find the midpoint of all of the sides, and then I would draw lines that create a perpendicular. Create a perpendicular, create a perpendicular. So those are the lines that I draw. Because of that information, then from that circumcenter to vertices, circumcenter to vertices, circumcenter to vertices, those blue distances are all going to be equal. And here's the reasoning behind that. If we put that triangle inside of a circle, and that vocab word is circumscribe, if we put that triangle inside of a circle, then these distances become a what? Yes, a radius. You got it. So let's sketch some circumcenters. So the first thing that I'm going to do is estimate where I think the midpoint on each side of the triangle is. Pause the video if you need more time. Then what I'm going to do is try to draw a perpendicular on that midpoint. So I'm being very careful to draw a right angle. Please pause the video while they try to finish up their triangles. And here's what you should be getting. We get a point of concurrency. So on our acute triangle, our point is inside the triangle. On a right triangle, it is on the triangle. And on an obtuse triangle, it is outside. Please pause the video if they need more time to work. So let's try an application of this. Boating. The positions of 3 boats are shown in a diagram. The boats are equidistant from a buoy. Where is the buoy? So let's construct a triangle and find the midpoint of each. And then you want to sketch in the perpendiculars. So once you sketch in the perpendiculars, it looks like our point of concurrency is outside the triangle. And here is an exact answer for what you should be getting. So what we're noticing from the buoy to the boat, buoy to the boat, buoy to the boat is going to be the exact same distance. Because if we were to circumscribe our triangle, then these blue distances would be the radius, so they would all have to be the same. Let's try another one. The perpendicular bisectors of triangle PQR meet at point S. So we're going to sketch these perpendicular distances. So we sketch this red, sketch the red, sketch the red. Then these blue or purple lines all become congruent. So PS and QS are both going to be 10. Our next point of concurrency is the incenter. The bisectors of the angles of a triangle are concurrent at a point equidistant from the sides of a triangle. So, if I draw the angle bisector, and the angle bisector, they meet at a point inside the triangle, and it will always be inside the triangle. Because of that, what happens is we get the distance to the edge, the distance to the edge, and the distance to the edge being the same length. And we talked yesterday that the distance to any point is the shortest distance, so that's why there's this perpendicular here, because that's going to be the shortest length from P to the side of that triangle. So the only difference now is if I were to draw my circle, with these being my radii, my circle, that was kind of a bad one, my circle would be inside of my triangle, like this picture right here. So then these blue pieces become my radius. And this word is inscribed. So now this circle is inside the triangle, so that is called inscribed. So let's analyze those two. A circumcenter, notice this page is not in your notes, a circumcenter is all the perpendicular bisectors. So if I were to draw midpoint perpendicular, midpoint perpendicular, midpoint perpendicular, all these red lengths are going to be the same because they would be the radii of this circle. The in-center are angle bisectors. So if I bisect the angle, and bisect the angle, then I come up with this point of concurrency in the middle here. So then our distances to the edge, distance to the edge, distance to the edge, those are all going to be congruent. And this is an inscribed circle. The angle bisectors of triangle TUV meet at point W. Find the value of B. Well, we're going to construct an angle bisector. So we have an angle bisector here, here, and here. So because of those angle bisectors, these orange segments are all going to be congruent. So we get an equation where orange is equal to orange. So 2D plus 7 is equal to 4D minus 1. Subtract 2D, add 1, divide by 2. What congruent statements can you write for this circumscribed triangle below? So that's a typo. So if we just imagine our circle here, from A to D is called a, radius. From D to B is a radius, and from D to C is a radius. So all those lengths are going to be the same. So AD is congruent to CD is congruent to BD. In the next question it says, one wall, each of an auditorium, a classroom, and a computer workstation meet to enclose a triangular courtyard. How can you determine where to place the table in the courtyard so that the table is equidistant from the wall? So we want to put a table in here so it's equidistant from the wall. So what we're going to do is find the midpoints of each wall and then draw in our perpendicular bisector. Does that look right? So our point is going to be outside of the triangle? No, so we don't want to do perpendicular bisectors. What do we want to do? Yes, angle bisectors. So sketch in your angle bisectors. And they should meet just above the Y or the A in courtyard, so then all those green distances should be the same. So what we were finding was the in-center. So here's a summary of what we learned today. A circumcenter is made up of perpendicular bisectors. An in-center is made up of angle bisectors. And a centroid we'll cover later, so if you want to write it down you can, is made up of medians. And a median goes from the vertex to a midpoint. So why don't you get your textbooks out or your PLDs out. We're going to start on page 305. starting on number 7 and 8. Please pause the video till everybody's ready. So question 7, it says, find the coordinates of the circumcenter. So we want to find our perpendicular bisectors. So this is 4 units long, so I'm going 2 over. This is 6 units long, so I'm going 3. And then I'm going to weight on that side. So if we construct a perpendicular, I end up here and here. And if 2 of them intersect, we can guess where that third one is going to intersect. So it looks like our coordinate of the circumcenter is going to be at this spot right here, which is the coordinate -2, -3. Number 8, the middle of our side is here. We're going to count these diagonals, 1, 2, 3, 4. So let's pretend that this is 4 units long, so the middle of that would be right here. 4 units long, so the middle would be right here. And now we need to construct our perpendiculars. So we'll see how I'm just creating a diagonal through those boxes, and this would be the y-axis. So then it looks like our point of concurrency would be right there, and that coordinate is the origin, 0, 0. So the rest of these problems you should be able to do, so you're picking up at number 14. This concludes lesson 5.2 for geometry. Have a good day.